Hello, Collegiate Academy, and welcome to week 2 of our math instruction. Today's lesson, we are going to be focusing on two-step equations involving integers. So per usual, we're going to go ahead and get ourselves started with our class pledge. So as I recite the pledge, if y'all could go ahead and follow along. Today, I will do my best to be my best. What I do today will make a difference in my life. My choices will affect me and those around me. I will listen, I will be honest, I will respect the rights of others. I will learn something today because today matters and my future is built on one now at a time. So before we start, I want to give us an example of what a typical two-step equation would look like, but also based off of our work from last week, I wanted to evaluate some key terms that have popped up a lot that I think we need to spend a little bit of time on. So these are examples of two-step equations that we see up top over here. There are 3 components to these types of equations that we really have to feel good about knowing and understanding. The first thing that I'm going to be mentioning, or the first term that we're going to be going over, is called a variable. So a variable is a quantity represented by a letter. So over here, if we looked at this equation, what will be the variable? C. It's just whatever the letter is that we see in the equation that appears. Likewise, if we looked at this equation over here, what would be our variable? X. Yeah, so the variable is a quantity represented by a letter. The other term that we need to feel good about understanding is what the coefficient is. So the coefficient is the number being multiplied by the variable. So over here, for this equation, we identified the variable as being what? C. The coefficient would be the number being multiplied by the variable. So what would our coefficient here be? -5. Likewise, over here, we mentioned that our variable term was x. What would our coefficient be? 3. The reason 3 is going to be the coefficient here is because that's the number that's being multiplied by the variable. And the last thing we have are our constants. So constants are fixed terms or numbers of that variables. So if we looked at this equation, I see 2 constants. What are those 2 constants? Yep, the -30 and the -5. They're just numbers that are by themselves. And likewise in this equation, I see 2 constants. What are my constants? The 23 and the 35. They're just the numbers that are by themselves. So moving along, now that we feel good about those terms, we can go ahead and jump into actually going over the steps on how to solve two-step equations. So step number 1 is going to be, you're going to find the value for the variable that makes the equation true. So what that means is that we're trying to figure out what we can put in for C that would make this side equal to this side. And likewise over here, we would try to figure out what I could put in for X that would make this side equal 35, okay? In order to do that, we are going to remove the constant term by using addition and subtraction, or subtraction. Then we're going to remove the coefficient using multiplication or division, okay? So going over that, or in theory, what that would mean is that, remember, we want to isolate the variable, what we talked about last week, to one side. So let's say I want to have a C on this side. The first thing I would do would be to remove the constant, which in this case would be -30, by using addition or subtraction. In this case, I'd use inverse operations and use addition to move it onto this side. Then I would remove the coefficient, which should be 5, by using multiplication or division. And in this case, what would be the inverse operation if these are being multiplied? Division. So I divide the -5 over, okay? Likewise on this side, the first thing I'm going to want to do is to move my constants. So what would I move in this case? Yeah, we're going to move the 23 on this side. And how do I move it? By subtracting it, since we're using inverse operations. Remember, that was from last week. And then I'm going to have a 3x equals something. How do I get rid of the 3x, or the 3? the inverse operation, which in this case would be division. So that's the theory behind it. We're obviously going to apply some steps, but before we're obviously going to do some actual problems, but I wanted us to kind of understand the theory behind it. Before we do that though, I want us to really re-emphasize that idea of balance, okay? Remember, our goal is to keep the equation balanced. So what we do on one side, we have to make sure we do to the other. So let's get into the good stuff, which is practice problems. I'm gonna go ahead and do a problem on this side all the way through. Then I'm gonna give you guys the opportunity to pause the video and work through this problem. So over here, we have a two-step equation, which is 3x plus 10 equals 22. I see all the components of an equation. So I see a variable, I see my coefficient, which is 3 in this case, and I see two constants. My goal is to have all the variables on one side and all the constants on the other. So let's go ahead and try to make that happen. If we go back to what we referenced a little while ago, our first step is going to be to move the constants by using either addition or subtraction. So in this case, what would I want to move? Yeah, I'm going to want to move the 10 over onto this side. So how would I go ahead and move that 10? By using inverse operations, and in that case, that would be what? Minus 10, exactly. So I'm going to go ahead and subtract 10 on both sides, right? Let's see what happens here. Okay, so if I have a 10 and a 10, these end up doing what? Canceling out. So on this side, I just have what? That's right, 3x equals, and what do I get when I do 22 minus 10? 12. So now I have 3x equals 12. I'm going to want to get rid of the coefficient by using either division or multiplication. In this case, what will be the inverse operation? Division. So I would divide this side by 3 and divide this side by 3. Okay, so these 3s would end up canceling out, and I'd be left with x equals 12 divided by 3 would be 4. So my solution would be x equals 4. If we wanted to check this, all we have to do would be to plug in 4 into x over here and see if that makes the equation true. So let's go ahead and see if that happens. I'm going to copy down my original equation, which is 3 times x. In this case, I just put 4 plus 10 equals 22. So let's go ahead and start multiplying this out. 3 times 4 would be what? 12. And if we added 10 to that, that would give me what? 22. So is it true that 22 equals 22? It absolutely is. So that's a way for me to just verify my work. But remember, we solved the equation over here. So now I want you guys to go ahead and pause the screen. Go ahead and try to solve this problem. As soon as you finish it, you can press resume play, where you'll see me work through the problem as well. So this problem over here, we have a very similar setup to what we did before. A two-step equation where we see the variable term, coefficient, and the constants. So my first step is going to be to do what? To move the constant by using either addition or subtraction. In this case, what would I use? Subtraction, because that would be the inverse operation. So if I have subtract the 9 on this side, what do I do on this side? Subtract the 9 as well. So I'm going to go ahead and solve that out. 9 minus 9 cancels out. So I'm just left with 6x equals, and what would 27 minus 9 be? 18. That's correct. Now, if we want to get rid of the coefficient, we use either multiplication or division. In this case, what would it be? Division, because that's the inverse operation. So I divide 6 on both sides. And I'm left with x equals 3. So my solution here to this two-step equation would be x equals 3. If you wanted to check your work, all you have to do is go back to your original equation and substitute this, or substitute 3 in for x. So let's see if that works. I would copy my original equation, so 6 times, instead of x, we'd put 3, plus 9 equals 27, right? 6 times 3 is 12, or 6 times 3 would be 18, my apologies. So we'd have 18 plus 9. And if we had 18 plus 9, that would give me 27. And is it true that 27 equals 27? It absolutely is. So that's the way for me to verify my work. Okay. So we're going to go ahead and clear the page. And now we're going to look at some examples of two-step equations with integers that have some negative integers in it, just because that's something we'll reasonably be seeing. Okay. So as we did before, I'm going to go ahead and walk us through this first one. And then you guys are going to have the opportunity to press pause on the video and work through the second example. So over here, we have negative 5r minus 3 equals 12. As always, I have my variable, my coefficient, and my constants, right? My first step is going to be to what? Move my constant by using either addition or subtraction. In this case, if I have a minus 3, what would be the inverse operation? Plus 3. So I would add 3 onto this side. And if I add 3 onto this side, what do I do onto this side? Add 3. It's exactly that. So let's go ahead and see what happens when you do that. The 3's cancel out, so I'm just left with negative 5r equals 12 plus 3 would be what? 15. It's exactly that. So now I just have my variable, a coefficient, and a constant, right? How do I move this coefficient over here? It's negative 5 that's in front of the r. Yeah, I use the inverse operation, so it's either going to be multiplication or division. In this case, what would it be? Division. So I'm going to go ahead and divide this side by negative 5 and divide this side by negative 5, which cancels out this 5, or these negative 5s, I apologize. So I have r equals, and 15 divided by negative 5 would be negative 3. It's as easy as that. So even though we have negatives, it's still, the process is going to be the exact same as we've been kind of going through. Okay, so my solution would be r equals negative 3. We're going to go ahead and I'm going to ask you guys do the same that we did before. If you could go ahead and press pause on the video screen now and try to work through this problem on your own. As soon as you finish, you can press resume where you'll see me go ahead and solve through it. Okay, so for those of us who are back, another example of a two-step equation. We have 7m minus 17 equals negative 24. Just kind of really stepping back a little bit, want us to remember our goal is to have all the variables on one side, all the constants on the other. Just reinforcing that idea, okay? So I want to move all the constants or the numbers over. So I just have m equals a number, right? Or the variable equals a number. My first step is going to be to what? That's right, move the constants by using either addition or subtraction. In this case, what am I going to be trying to move? Negative 17. And how would I move it? Or the minus 17? And how would I move it? By adding 17. So I'm going to go ahead and do that. 17 on this side. If I add a 17 on this side, what happens to this side? I also add a 17. Okay. So these 17s cancel out, and I'm just left with 7m equals, now be careful because there is a negative over here. So negative 24 plus 17 would give me negative 7. Okay. Remember that if you guys are adding signs in this case, or integers with different signs, a trick that you can use would just be to subtract the 24 and the 17 and just take the sign of the bigger number. So 24 minus 17 is 7, and then you just make it negative because that's what the larger integer was. If you prefer to use a timeline to do that or a number line to do that, you absolutely can. As long as you're aware of whatever process works for you, as long as you're aware that one of the items is a negative and one's a positive. So now we have 7m equals negative 7. My goal is to just have m equals something. So in this case, what would I use to get rid of it, or to get rid of the coefficient? That's right. Whoopsies. So in this case, to undo or to get rid of that 7, I would divide 7 on both sides. This would cancel out, and I'd just be left with m equals not 1, but negative 1. And that would be your solution.